Today we're going to be talking about using the properties of exponents to simplify expressions. First, let's talk about the product of powers property. Before we start that, I do want to remind you of one little thing, and that is that if you have a variable like x, that there actually is an exponent that's understood on there, and that would be to the first power. That is very important, and it's an easy place to forget and an easy place to mess up. Okay, so let's do an example first. Well, first let's look at this in an algebraic way, and that is a to the m power times a to the n power equals a to the m plus n power. So if you're multiplying like bases where the a's are the same, you add the exponents. Let's do an example of this. Example number one. Let's do this example first without using the property. We'll do it the old-fashioned way, the long way, and then we'll do another one. We'll do it again using the property. So let's say that it's going to be x cubed plus x to the fifth, not plus, times x to the fifth power. There we go. That'll work. So if I write x cubed in expanded form, that's going to be x times x times x. Remember, that's for the x cubed. If we look at x to the fifth power in expanded form, that's x times x times x times x times x. And so if we look at it as how many x's are we totally multiplying together there? We're multiplying a total of 8, which would be x to the 8th power. Now let's look at this using the property. So if I just have x, there we go, x cubed times x to the fifth power. This is going to be x to the exponents are 3 and 5, so we add those, so it's going to be 3 plus 5, which equals x to the 8th power. Okay, now let's look at another example of this. Let's do example 2. And let's do 3x squared times 4x to the fifth power. Okay, now the regular numbers are still regular numbers. So this is still 3 times 4, and 3 times 4 equals 12. And now we do have the like bases. We have x and x, so this is going to become x to the 2 plus 5 is going to be the exponent, which is going to equal 12 x to the 7th, because we add the exponents. Again, regular numbers are still regular numbers. Let's do one more example on this, and you're welcome to pause it at any time, try it yourself, and then see if you get the same thing. So this is going to be x times 2x squared y times 4 x cubed y squared. Okay, why don't you pause this and see what you get, and then you can watch me finish it off. Okay, here we go. So let's multiply our regular numbers together first. 2 times 4 is 8. And then if we look at our x's, what's the exponent understood on this x right here? That's understood to be a 1. So I'm going to put a little 1 on there, just, whoops, find a pin that works. A little 1 on there to make sure I don't forget it. So this becomes x to the 1 plus 2 plus 3. So I'm actually going to write it that way, 1 plus 2 plus 3. And then let's look at our y. Here's a y without an exponent, so it's understood to be 1. So I don't have room, so I'm going to have to kind of make it fit right there. So this is going to be 1 plus 2. And so now if I look at all that, this equals 8 times x to the 6th power, y to the 3rd power. Please let me know if you have any questions about that. Okay, so the next thing is the power of a power property. And let's look at this algebraically first. So if this is a to the m power, all of that to the nth power, a power raised to a power, we're going to end up multiplying. So this is going to be a to the m times n. An example for here. Let's do example 1. And this is going to be x cubed to the 4th power. Let's first do it without the property. So let's just write this in expanded form first, which means that this is going to, x cubed to the 4th power is going to be x cubed times x cubed times x cubed times x cubed. I'm going to go ahead and use the product of powers properties where we're going to add the exponents here. We could go ahead and write it out in expanded form as well. So this is going to be x to the 3 plus 3 plus 3 plus 3 4 times. And if I add all those 3's up, I get x to the 12th power. Now let's do it just using the property. So this is going to be x cubed to the 4th power, which is going to be x to the 3 times 4, and 3 times 4 is 12, so the answer is x to the 12th power using the property. Okay, so far if we're multiplying our like bases, like in number 1, we add the exponents just for those like bases, which means that they all have to be x's, they all have to be y's, they all have to be the same variable or the same number as the base. For the number 2 was the power of a power property, and that's a power raised to a power. You multiply the exponents. And then this last one is going to be the power of a product property, and product just means things that are multiplied together. So with this one, if this is going to be, if we're saying we have AB, and then we're going to have that to the mth power, this says that this is a to the mth power, b to the mth power. So you're taking it and you put it on each of the bases that are in there. Example 1 on this one. Let's do xy to the 5th power. So for this one, it goes on each of these. So this becomes x to the 5th power, y to the 5th power. And on that one, we're finished. Also, I guess one thing I should have mentioned is what's the exponent understood on this x right here? It's a 1. The exponent on the y, because it's not shown, is a 1. 5 times 1 is 5. 5 times 1 is 5. Let's do another example here. Let's do example 2. And this is going to be 2x cubed y to the 3rd power. Okay, we'll do this one together, and then I'll give you one that I'll have you pause and try on your own. But for right now, what is the exponent understood on this y right here? That's a 1. Let's go ahead and mark that. It's the easiest place for students to mess up. So if the 3 goes on everything, so this makes this 2 to the 3rd power, x cubed to the 3rd power, and then y to the 1 to the 3rd power. 2 to the 3rd power, 2 times 2 times 2 is 8. So this becomes 8. X to the, when we're multiplying, or a power raised to a power, we multiply. So again, this is using the ones we've already used. So it's going to be the 3 times 3. I'm going to go ahead and write it that way first. Then this is y to the 1 times 3. So this becomes 8. 3 times 3 is 9, so it's going to be x to the 9th. 1 times 3 is 3, so it's going to be y cubed. And there we go. So let's do another example. This is going to be example 3. And let's do 3 x squared y times negative 4 xy cubed squared. So this is going to combine all 3 of these. So if you'd go ahead and pause it and give it a shot. Okay, let's see how we did. Let's take care of our power raised to a power first, or our exponent out here, our power of a product property. I'm going to go ahead actually before I do that, and I'm going to put a little 1 on that y and a little 1 on that x, just so that I don't forget they're there. Then this becomes -4 squared x to the 1 squared and y cubed squared. So -4 times -4 is +16. Remember with the calculators, if you don't put it in right, it'll tell you it's -16, so you have to be careful. Also, just make sure that the answers you get make sense. Then this is going to be x to the 1 times 2 is 2, and y to the 3 times 2, which is 6. Okay, so that's how that simplified. Now we're going to bring this down. And so we have our 3x squared, y to the 1. So now we're going back to the very first examples we did in here. So 3 times 16 is 48. That's our regular numbers. That still doesn't change. We multiply our like bases. We add our exponent. So it's going to be x to the 2 plus 2. And then y to the 1 plus 6. And if we simplify that, we get 48 x to the 4th, y to the 7th is how that simplifies. Okay, again, please let me know if you have any questions. Just as a quick little reminder, that assignment number 1 for this one. Actually, let's just stop right there. Let me know if you have any questions.